Hello, everyone, and welcome to our BlackTIDES training event. We are Black in technology, informatics, data science, epidemiology, and social science. Our 2023-24 Executive Committee consists of Kimberly Deas, who is our Informatics and LinkedIn lead, Sia Seiko, who is our Strategic Operations, Twitter lead, and Communications lead, Andrea Hobby, who is our epidemiology lead, Lauren Shores, who is our mentoring and networking lead, Hannah Hanfi, who is our statistics lead, and Natasha Wooten, who is our graphic designs lead. Thank you for attending. We hope you enjoy today's presentation. All right, thank you everyone for joining. And welcome to the part 2 of R for Healthcare Informatics and Data Science. I'm Kimberly Deas. I am the co-founder and informatics lead for BlackTIDES. And today, again, I'm going to do a very brief introduction to R programming. And the information that I'm going to share will be available at our GitHub site. See, I don't know if you had a chance to check that out, but we have a GitHub site now. So that's where we're going to post all of our code. So now what I'm trying to do is just to get the presentation going, and then we're going to get right into it, just in case you guys have questions afterwards. All right, let's get this party started here. Okay, we're going to play from start. And I should probably share screen so everyone can see what I'm looking at. All right, if I could get another thumbs up if everybody can see, because I won't be able to see you. Fantastic, thank you very much. Okay, so this is coding for R. Now, is the font and all that, is everything clear for everybody? Another thumbs up if it is. Okay, all right, so that was a thumbs up because I actually wasn't looking at the time. Thumbs up if everything is clear, because we had some issues with our recordings before. Okay, fantastic. All right, so let's go ahead and get started. This is coding for R for Healthcare Informatics, Health Data Science. You know who I am. I'm a PhD candidate in healthcare informatics. I'm also a chemical and health informaticist working for a local company here in DC. In my volunteer time, I try to work to help people's data careers be productive and successful, and then help them move on through the chain of command so they can get to whatever level they're trying to get to. All right, so this is going to be an introduction to R for healthcare informatics and health data science. I'll cover some of the basics. We'll talk a little bit about installation and setup. However, I did put that information in the Eventbrite, so hopefully you got everything that you needed in order to be able to code along with me. I'm not doing anything too terribly fancy or difficult, so hopefully it'll be easy for you guys to code along. I'm also going to do a little bit of data manipulation and data analysis and data cleaning, my absolute favorite thing to do. I'm kidding, it's not. And then we'll end, of course, with a live coding of a healthcare data set. So this is an introduction to R. First, we're going to talk about what R is, why it's useful, and this should say in data analytics, and then why R is useful in healthcare data analytics, and then I'll share some resources for R. I'll collect those slides before I put them in the GitHub. Okay, so many of you may know that R is a very versatile programming language in software environment. It's highly regarded for statistical computing, easy for me to say, data analysis, and data visualization. It's an open source tool, and what I can tell you from experience is that R has one of the most supportive environments for asking questions that you'll ever want to meet. One of the organizations that I'm a member of is called Women in R, or is it R for Women? I can't get it confused now. At any rate, they have very enthusiastic people that are willing to help you. You'll get a lot of support and help. And again, because it's an open source tool, you get expertise from lots of different people from all over the world, which is really great. So there's a lot of, packages for statistics and packages for data manipulation, and that's why R is such a common tool, especially in healthcare. One of the really big advantages of R, though, for healthcare is that it handles very large data sets really, really well. I do machine learning in R. I actually did the analysis for my dissertation project in R. Syntax is straightforward. Not sure I necessarily agree with that, in the sense of if I were learning a programming language, this would be the one I would learn second. I would probably learn something like Python or SQL first. That's just my own personal advice. R also integrates a lot of different languages and other types of coding platforms. I actually use it. I don't use it in Python, but I do use it in a low code, no code software called KNIME. So it works really, really well with that. And that's why it's a really popular software. So I mentioned that we use R for statistical and data analysis, and from everything from linear regression to time series, which is really, really important. A lot of the analysis that we do, particularly in healthcare, has to do with timing of things. And so that's a really important function that we have in R. There are also a lot of contributions that are made to R. So I talked about the environment where you can, go online and you can find a community of people that are always willing to help. So there's always people contributing to creating new packages. And if you want to take something like that on your own, you can do that. R also has an advanced plotting system, so it produces really great visualizations, and I'll be able to show some of those to you using ggplot, which is a function in R. Okay, what have I done here? Click the wrong thing. Give me a second. All right, I hope this KNIME doesn't open up. I accidentally clicked on it. I don't know how I did that. Okay, so I mentioned again about R. Do you guys see KNIME showing up on your screen?
You're good.
Okay, you don't? Okay. I accidentally clicked on KNIME, so I'm going to have to click off of it at some point. Let me see if I can quit it now. 1 second here. Yeah, let me force quit. Okay, it's in the background. All right. So I mentioned again why R is useful in healthcare. I won't go through all of this. I want to spend some time actually doing some coding and answering any questions that you have. Again, all of these slides and the code will be available in our Good Help site, and we'll provide links to that later. Okay, so R resources. For me, the definitive book in R is called R for Data Science. This is Dr. Hadley Wickham's second R book. If for some reason you can't get the second book, the second edition of his book, because I think it's about sold out. I checked the other day. His first edition actually is pretty useful as well. I think in the second one though, he went more into some more advanced techniques that we use in R, but for the most part, if you only have or can get access to the first one, it'll be a great start for you. I highly, highly recommend this book. As it relates to R courses, Udemy has an R course that I've been taking with a gentleman named Kirill. I actually originally learned Tableau with him, but he also teaches R, he teaches Python. He's just a really great professor. The courses are only $12.99. Now, the challenge there is that it's not like Coursera where they kind of stay on you a little bit to stay on top of things. So if you're really good about staying on top of things, I would highly recommend this R course. It's inexpensive, and Kirill is a great teacher. Now, I put others in question mark because if any of you have any resources that you'd like to share, please feel free to put them in the chat so that others can be informed. All right, so now we're going to start with the basics of R. Again, I'm not going to go through details of how to install R or RStudio. I provided that in the Eventbrite. There should have been a link there. The link here is very straightforward, tells you everything you need to know about how to install R in RStudio. And just an FYI, if you want to use RStudio, which is an IDE, which is basically a coding environment with a lot of fancy features like colors, and it'll tell you if your code is wrong and all that. I highly recommend that as well, as opposed to coding in the terminal. You will need to use R in order to use RStudio, so you have to install both. And this is the link in order to do that. Again, that was provided in the Eventbrite that I sent, or that was provided to register for this event. Okay, so this is what R looks like at the console. Again, some people like to code in the terminal. I personally do not. There actually is a console section as part of RStudio, and I'll show you that in a second. So this is what our console looks like if you just want to code at the terminal. Again, it's just whatever you want to do. I know a lot of software engineers typically like to use the terminal. They consider that real coding. I remember when I first started working, I worked 10 years ago, I was working with a group of software engineers, and they thought anyone that used IDEs was not a real coder. And I'm like, I'm coding all the way to the bank. So, we're just going to kind of ignore that. I don't know that they're saying that anymore. But anyway, everybody I know uses an ID is just much more useful. At any rate, this is what the R console looks like. And I love R, and that's what I type in here. I won't do a demo of that because we don't need to use it much. Again, it runs in the background of RStudio. I will do a demo of this, though. So this is what a screenshot of what RStudio looks like. And it's divided into 4 sections. I'll go into some details about what the 4 sections are. I think in the next slide. Yes. Okay, so the first section, the upper right, was a source pane, and that's where we write and edit our code. And I think what I'll do right now is I'll stop sharing this screen and I'll start sharing this. Well, let's see. No, I'll tell you what. Let me just finish going through this verbally, and then when I open up R, I'll go through the explanation again. Okay, so the upper right hand or the upper left hand pane is where we write and edit our scripts. Right below that is the console pane. To the right of that is the environment and history pane, and above that, or below that actually, are the files, plots, packages, and help pane. So again, probably went over your head, and that's okay because we're going to go to the console in a second. All right, so this is some basic syntax about R. Again, I'm going to do a demo of this in the console, but for now, I put it into the presentation just for future purposes if you wanted to use it and look through it. So just like in Python or any other programming language, you have different types of variables. You create variables and you have different data types. So this first variable we're calling age. This greater than sign with the hyphen is called an assignment operator, and we are assigning the value 30 to we're assigning the number 30 to the variable age, and that's a numeric type. The second one is patient underscore ID is our variable. We're using assignment vector P001. That's a character type because we have a mix of letters and numbers. And then you also have logical types. Again, just like other programming languages, here we have if the variable smoker, we have the assignment variable or the assignment operator, and we're saying that that is equal to true. So if I put this into the coding environment, what we will get back are these variables if we just call them. And for those of you familiar with programming, you know what I mean when I say that. All right, so you can also do basic operations in R. Here we have a variable called new underscore age. We use the assignment variable. We're going to say it's age, which we know is 30 plus 1. Again, I'm going to demo this in a second. And then we're going to tell the console to print new age, and we'll see that printed in the console. We also have different types of data structures in R. Here we're going to talk about vectors, matrix, list, and data frames. So here we have a vector. This C is for concatenate or combine, and what we're doing is we're combining the letters 1, 2, and 3, which have to be separated by a comma, into a vector that we're going to call, it says vector, this actually should be data 1. So just as a note for those of you, especially if you're new to programming, make sure that when you use a variable name, make sure it's something that makes sense. This one, I should have gone in and corrected the slide. This should be called data 1, and you'll see when I do the live demo that it's actually called data 1 and not vector. You don't call a vector vector. That just doesn't make any sense. So pardon that error. I will make sure to make the correction when I provide the slides to you. Same thing with matrix. You should not call it matrix. You should call it something else. Matrix 1 or something like that. I typically use letters and numbers when I'm creating my variables. So for example, I called it data 1, data 2, and that way when I'm creating my new data sets, I know how to go back to, if I have to go back to an earlier copy of my data, I'm able to easily do that. All right, so moving on, we also have a matrix. And so this is, for those of you who've had linear algebra, you'll be familiar with the term matrix. So here we have a matrix from 1 to 9, and we have the number of rows are 3. And so when we print that out, we should see 3 columns and 3 rows that will make up our matrix using the values from 1 to 9. We also have list. So this is not like list that we see in Python. This is a different kind of list. At any rate, you have to remember to use the word list. So again, this is a terrible variable name because it should include, it should never include names that are reserved names, right? So list is a reserved name in R, so I should not have used list. So again, I'll make that correction and provide it to you when we share the slides on GitHub. So at any rate, this list contains age, patient ID, and smoker. So basically, we're combining other variables into a list, and it'll print a list similar to what we see in Python. And then lastly, we have data frames. So those of you that code in Python are familiar with data frames. Here we have a mix of different types of, we have numbers and characters, and that's what you can combine in a data frame. With a list, they all have to be of the same data type. With a data frame, you can combine numeric and you can combine logicals and characters to create your data frame. So here we have ID, we have C, again, we're combining or concatenating the numbers 1 and 2, and then we have name, and then we have another vector that we're concatenating and calling Alex and Bob. And so when we print that out, we should see Alex assigned to number 1, Bob assigned to number 2, and I think we're going to go into our, yes, so now we're going to go to the console. Now, the next step before we skip to that, though, I just want to talk about, just before you import your data, you should always take a look at it. Like that should be step 1 without equivocation. Don't look at it once you put it in your IDE, because sometimes you'll miss things that you would have seen if you had looked at your data in Excel. So now I'm going to stop sharing the screen. And actually, I think I'm going to stop and ask if there are any questions. And you can let me know if I'm going a little bit too fast as well, because looks like we got plenty of time. So at this point, does anyone have any questions? Okay, so I'm going to pull up the data. I'm going to pull it up now, and then I'm going to share screen. And again, I just need you to tell me if it's legible. Okay. Alrighty, let's share this window. Our data, and please make sure it's legible. Give me a thumbs up. I had some issues with that before, which is why I'm gonna keep bugging you guys and asking. So is that legible for everyone? If you can give me a thumbs up or a thumbs down if it's not. Okay, fantastic. All right, so I always say, look at your data before you import it, okay? So we can see we have a number of columns here. One of the other things that I do is I will filter my data as well. And I'm doing this for a reason. I'd like to have an idea about blank spaces and NAs before I import my data. Now, everybody is different when it comes to this task. You can do it however you want. You can actually absolutely correct those things after you import the data. This is just kind of an old habit I have of just kind of going through before I ever even import it to make sure that as much cleaning as I can do in Excel is just much easier than to write code out, right? And I'm just more used to working in Excel like a lot of people, right? Before all these programming languages came about. And I just probably gave my age away. So I know ahead of time that there are 3 columns I'm interested in. I'm interested in total cholesterol, age, and BMI. And those are the 3 that we're going to do some additional analysis on. So knowing that ahead of time, I would go to my age column. And again, I'm doing this for some from stakeholder. They want some information about total cholesterol by age and BMI. Okay, so I'm going to look through. I'm going to do a filter in Excel to look at my data. I always scroll down to the bottom. So I see here that there are no NAs and there are no missing values, which is great. I'm also going to do the same thing with total cholesterol. Let's see what we got here. Okay, so we got some blanks here. So that means we have to do something about that because, and I normally would do something about it on the front end. And what I mean is that I would look for all of the blank spaces and then put NAs in all of the blank spaces because I know that programmatically I can handle those blank spaces, okay? So the other column that I want to look at is, I think, BMI. Did I say BMI? Yeah. Okay, let's see if we got any blanks there. Okay, so we got some blanks. Okay, so on the front end, the first thing I'm going to do a Control F, and I'm going to look for all the blanks, and I'm going to replace them with NA, and I'm going to go replace all, because again, I know I can handle all of that once I import my data. So we have over 9,400 replacements, so I'll hit close, and then I'll save my data, and now we're ready to import it. So you might notice that there were some blank spaces in glucose. We were able to see some of those without scrolling through. This data set is pretty large. Let's see, how many rows is it? I think it's like 4,200 rows, or something like that. Okay, so now that we've replaced all of our blank spaces with NAs, now we're going to close that out. And now we're ready to load our data set. So here's where we're going to start our coding. So I'm going to switch over now to our analysis. Hang on a second, I've lost my mouse. Okay, and where's my mouse? Give me a second, guys. That's what I hate about using this roller mouse. Okay, there we go. All right, so now I'm going to go straight to our coding environment. And again, please thumbs up if you can see it and if it's clear. Okay, Sia, do you have a question?
Yeah, I had a note a while back when you were showing the filters. I don't know if everyone was able to see the pop-up screens when you were filtering. It's fine. We can add those in for the ones who will watch the recording, and we'll edit this portion out, but it's fine. But I just wanted to check with everyone if they were good.
Yeah, the data set and everything that I'm showing today will be included. There'll be a link to our GitHub site where you can check for when we're going to import that. So everything will be available for you to review on your own. And what I would suggest you do ahead of time is where I've looked at certain variables, BMI, age, look at some different variables, kind of play around with what I've done here. And that's a really great way to get skilled on how to do analysis in R. Okay, so everyone can see that real clear, correct? All right. So the first thing that we do, we're going to load our data set. So this will be part of our data analysis section. All right. Okay, so we do that we created a variable we're calling CVD data. We use the assignment operator, and the operation for, or the code for reading our data is read.csv. And then we're going to call our data set is called datacvd.csv, and it's in parentheses. Now, before I go on, I mentioned that I would explain about the panes again. This pane is our coding pane. It's where we have, our editor, where we put our code. Now, you don't have to use this. Sometimes people will close this pane and just use the console pane, because everything we do in this upper left pane will show up in the bottom. So I'll just do a demo of that. And we will run. And you'll see in the console pane that the data that we just uploaded shows up where we can visualize it. Now, we mentioned that this is called, the upper right-hand corner is called the environment. So you can look at the environment, which is basically tells you the data that you just uploaded, any other operations you did. It'll give you your history. These are some of the history that I did before I started to get practice for tonight. What other connections? So this would mean if I wanted to connect to a database, and then a tutorial on if I wanted to know how to do, specific packages in R. So for now, I always leave this with my environment. Now, if I click here, what it will do is it will show me the data set in the upper left-hand pane, which is the coding pane, what I call the coding pane. So you can, basically scroll through and look at it just as you would an Excel spreadsheet. So this is a really cool feature to me of R versus like any other programming language. You kind of see it right here, right along with your code. Now, this lower right-hand pane is the files, plots, and help pane. And as it says, it gives you all of the files, gives you plots. These are going to be where we're going to see our graphs, the packages that we're going to use. So in this particular case, we're going to use a package called ggplot, which is going to give us images. And then we also have help here as well. So we have two sources of places where you can get the tutorial up here, you get your help down here. Okay. Now, when you get to R, when you open up RStudio, the first thing you're going to want to do is to set your working directory. So you do that by clicking on this, what I call the settings button. I don't know if that's actually what it is. And then you click set as working directory, and it will set whatever directory you're currently in as your working directory. Now, if you want, you can go to a working directory, in which case it'd be like any other programming language where you would actually have to type in the path to the directory that you want to be in. So I had all of that already prepared. This is my BlackTIDES folder, the events 23-24, events Kimberly, and an intro to R for healthcare data science. And that's the directory that we're in. All right, so now that we've read in our data, we can look at it here. But one of the other things that a lot of people do, like we're in Python, we'd probably do something like head CVD data, and you can actually do that in R as well. Head works the same. And then we run, and then we end up with the first 6 rows of the data set. Okay. So now we are going to go to the next stage, which is going to be data manipulation and cleaning. Now, I just want to say ahead of time that everything I'm going to show you code-wise is already in the slides. So when you go to the slides after the presentation, everything will already be listed there. But I'm just going to go straight through the code for purposes of having enough time to go through everything and taking any questions at the end. Now, one of the tricky things about coding is you always have to make sure that all of your data is the right data type. So for example, if you recall from working in Excel, there's an option to format your cells. And so I had this data set. It's a cardiovascular disease data set that I think I got off Kaggle. And unfortunately, there was numeric information that was formatted as characters instead of as numbers, which means that when I went to try to do the data to prepare for this presentation, to analyze the data, I got a lot of errors. So I had to clean up, figure out how to clean up all the errors. So this is a big part of being a data scientist, a lot of data manipulation, a lot of data cleaning. So what we're going to do first of all, I already know ahead of time, again, that the 2 columns I'm interested in, BMI and age, I already know ahead of time that those columns should be numbers instead of characters. But one way to check that, and then I'm going to jump ahead a little bit, is if I were to go to summary CVD data, and it'll tell me some information. Structure CVD data. It'll tell me, what structure the information in all the columns is. Okay. So this is jumping ahead a little bit to look at, this is again, just kind of perusing your data. But this is something, again, in the data cleaning and in data cleaning step, you should always do this, because before you start doing your analysis, or you end up having a problem that I had, right? So if I had checked my data before I tried to analyze it, I would have known that it wasn't structured properly. But let me just show you how that works. So STR is the code for looking at the structure of your data. So basically the data type. So we run that. And so what we end up is this kind of an output, where each column is listed, and then we have the type of data in that column. So for example, for the sex column, it's a character with, letters, male, female, that makes sense. Random ID, integers, has numbers, that makes sense. Age has integers, that makes sense. But if you go down to BMI, it says character. And then it has these numbers. Now, what I originally tried to do was in Excel, I tried to correct it by, going to format, cell, then changing it to number. For whatever reason, that didn't work. So I ended up having to come to R to change, to force those characters to be numbers. And here's the code that I had to use to do that. So again, this is part of data cleaning. And you'll want to do this before you start doing your analysis. So I had to change the character columns, or the data in the BMI column, to numeric numbers. And then I checked it again to make sure it was correct. So here we have, what we're doing here is I'm looking at the CVD data set. I'm looking for the specific BMI column, and I do that by putting a $sign in between CVD data and the column that I'm interested in. I use the assignment operator. As numeric is the function that I use to change the characters, characters in the BMI column to numbers. So it's as numeric as character. So we're changing from character to numeric. So and to me, it's not as intuitive. I think it should say character and then numeric, but it doesn't work that way. The first thing you write is the thing you want to change it to. So that's as numeric. The thing that it currently is as character, and the column that we are wanting to change from character to numeric is the BMI column. Then we'll look at the data again, and then we'll do another string CVD data to make sure it went okay. All right, so I could just look at where's BMI. Okay, so you can't really tell if it's the right thing or not, but if I run this again and look at BMI, it should now all be in numbers. And we see that it is numbers, so we just clean that up. So this, let me just go ahead and copy this, because I'm gonna actually use this very code. I'm gonna download it and put it in our GitHub site for you to use. So I wanna use the actual code. Okay. All right. Oh, thank you, Sia. Yes. So important point. These hashtags are what I use to comment my code. And I do this because I don't actually want to run it. I want to be able to come back at some point in the future and say, what was I doing there? What was the point of that? And I'm telling, kind of listing out everything that I'm doing. And I do that with a hashtag. The other really cool thing about RStudio is that you see that I have this dark background with all these different colors. You actually have the option to change to any, I think they have like 25 or 30 different types of backgrounds that you can use. You can use a light background, you can use whatever kind of background you want. There's lots of different colors. They actually have people that have created their own different, types of backgrounds, and they, publish them to the R site, and they actually use them now. So again, that open source community is really, really great. And a lot of the really cool colors have been created by people that just use R. But me, I went with this one. I like it. It works. Okay, thank you, Sia, for that reminder about coding. And that's another thing. Always comment your code. Like, just use good variable names and always comment your code. That's just kind of how it should go. Alrighty, so let's go to the next stage. Now we're going to do, let's see, we looked at our data types, we converted what we needed to, we looked at our NAs, and now we're going to handle some missing values. So you might have noticed that we had quite a few missing values. And so what we're going to do now is, and then I'm going to stop and pause for a second. Okay, let me take a drink for a second here, excuse me. Okay, this is eggnog, but there is no rum. Okay, and that's the story I'm sticking with. Okay, so when you're dealing with healthcare data, you have to be very, very careful about how you handle missing values. And what I mean by that is you can't always impute the mean and then, replace that number with everything in the data set. I'll give you an example. You have a group of patients, some are responding to cancer treatment super, super well. Others are just not. So you got data that's on extremes. And then you have patients that for whatever reason, their data about how they're responding to the therapy didn't work. When something is life or death, you probably don't really want to impute the mean, especially if the data is already on extreme ends for whatever reason, right? And I'm just making this scenario up. But what I'm saying is that when you deal with healthcare data, these are the thought processes that you have to have when you're analyzing the data. You can't just impute means and, take a random number or use the mode. You just have to think super, super hard before you decide to actually replace values, because again, it could be life or death for a patient. Okay, and I keep losing my mouse here. Okay, so that's the lesson on imputing data. But for purposes of this test and for purposes of BMI, right? There are over 4,000 patients in this data set. I'm comfortable using the mean BMI to replace my NA values. I'm comfortable with that. But if this were cancer treatment, or if this were high blood pressure among people living with HIV, give it a whole lot of thought. And I also say, this is one of the challenges I have communicating with stakeholders, because a lot of times stakeholders aren't data professionals. They just want a data set. They wanted to say what they wanted to say, but you have to be very mindful and be an ethical data professional. And yes, this has cost me my job, being an ethical data professional. But oh well, obviously it worked out great because I have a job now and I'm here to teach you guys about R. So it worked out. But just be very mindful of what you're being asked to do. And don't be afraid to stick up for your patient. Quite frankly, don't be afraid to be ethical. Don't be afraid to be mindful. There's a way to do it though, be professional, right? Always do that. But you have to push back on people that want you to do unethical things about data. That's all I got on that. That's just, that's my my statement for the night. Okay, so we're gonna handle these missing data for the BMI column by taking the mean, and we're gonna have that value carry over to the rest of the data set where there are missing values. And here's how we're gonna do that. So again, we're looking for the BMI column. So it's CVD data, $, the BMI column. And then we have to use brackets here. Is NA. If there is a NA present, then we're going to replace it with the mean. So here, again, we do an assignment operator, because we're calculating the mean of that column, and we have the NAs present, that equals true, right? So that means that everywhere there's an NA present, we're going to replace it with the mean. And that's what this code is. Then we're going to recheck. I have here recheck column for NAs. I'm not sure why I have that. Okay, let me delete that out. I would say just look at your data, right? Every time you do a manipulation, look at your data. Something else I typically do too, and I'm not doing it here, but every time I create a new data set, I will often give it a number. So I'll do CVD data 1, CVD data 2. I'm not doing that here because this is just a short analysis, but like say if we're doing like analysis that I thought could potentially be about, 50 rows of code, I might do CVD data 1, data 2, because I might need to go back to a previous version. I might have done something that I shouldn't have done, or the stakeholder doesn't want people over 18, they want people under 18. And if I've changed the name every time I create a new data set, then I'm able to go back to the most recent step. If I use the same name, then I got to go back to the beginning. So that's just something else to keep in mind. I usually change the data name, the variable name, as I'm going through, but I'm not doing it this time, and it's fine. Like I said, this is a short set that I'm doing here. All right, so we know that the BMI column has been given our mean values. And I kind of know that because I remember when I looked at the data, again, why you look at the data first, within like the first 50, there was an NA, and the NA was no longer there, is no longer there. Or the first 25 is no longer there. So I'm pretty confident that there are no NAs there, but you can check if you want. Okay, so let's say if we do want to check. The way we would do that is we would, there's a special function that we do for that. Now this is kind of jumping way ahead, right, into the sapply, which is a specialized function in R. I won't go into too many details in terms of explanation because this is just a beginner's course, but the references that I provided for you will give you more than enough information if you want to get some more details about that. But for now, for what we're going to do, we don't really need to know it. I'm putting it in here because this is the code that I use to check for NAs. And again, what this is going to do is going to count the number of NAs left in the column. Now, remember, we were supposed to have replaced them all in the BMI column. So we shouldn't see any NAs in the BMI column. So let's just see what we get when we run that. Okay, so it looks like we have no NAs in the BMI column. Looks like we have no NAs anywhere left. Okay, cool. All right, so now we are ready to go on to the next stage of our data, and this is much more exciting. So this is just kind of what you're going to spend a lot of your time doing as a data professional: cleaning, munging, merging, checking for NAs, imputing data where you can, where it makes sense. That's a lot of what you do before you get to the fun stuff of actually doing some analysis and actually getting some graphs and things like that. Okay, so there's one last thing that we're going to do. This is in the category of data transformation. Stakeholder just came to me right in the middle of my analysis and said, hey, I really only want people, I really want to see this data, additional information. I want to see the above 50 and the below 50. Now, again, this is where having subject matter expertise kind of comes in handy. The first thing you should think anytime someone, especially if they don't have the expertise that you have in terms of the data set, want you to do something, ask yourself why. So in this case, we're looking at cardiovascular disease. We're looking at above 50, below 50. Does anyone want to unmute themselves and tell me why this would be a good idea, or why it wouldn't be a good idea to look into something like this? And if you're shy to unmute yourself, you can put some information in the chat if you like. No takers on why it's a good idea why it would be a good idea to look at people above age 50 or below. This is a cardiovascular disease. The stakeholder wants, and you know what, I have to go back and put the question in. So the stakeholder wants some information about age and total cholesterol and age and BMI. So what does age 50 have to do with anything? These are questions that you need to ask. Okay, so that's a very good point. Younger patients typically don't take medication. Okay, be a little more explicit. What do you mean by take medication? Because we're talking about above age 50, below age 50, we're looking at age, we're looking at BMI, and we're looking at total cholesterol. So don't take medication for what? What would they be taking medication for? What do you think the older people are taking medication for? Maybe I should ask that. Anybody else want to chime in?
It's not something.
I'll unmute myself. Typically, like over 50 has a higher cholesterol, or somebody might have some comorbidities such as diabetes, some type of heart disease, and they'll be on the statins.
Very good point. So that might be a good reason that we want to look at, the stakeholder wants to look at above 50 and over 50 because they're thinking they're going to see some differences in diabetes incidence, BMI, total cholesterol, what else we have? Glucose, heart rate. I mean, just practically everything on here is different for people over 50 than it is for people under 50. So again, these are just, basic questions that when you're being asked to analyze data for a reason, be able to explain why, and ask yourself why. Why does this make sense for us to do it this way? Okay, so here we're going to add some additional information to our data set. Let me just scroll down. Okay, and what we're going to do is what's called a data transformation. So here what we're going to do is we're going to create two new columns. We're going to have one for above age 50. We're going to have another for below age 50. Just as our stakeholder asked us. And then we're going to take another look at the data to see what it looks like now. Okay. So again, this is a little more complicated. So this is if else, the very same as it would be for Python or something like that. But for me, I think this is a lot more straightforward. At least I'm able to read it. Now, some people would have all of this code on one line. I prefer to put the different things that we're looking for on different lines, just so that I'm clear that they're different, right? So I have my if else statement. I have where I'm looking for the age column from the CVD data greater than 50, right? Comma. Then I have in parentheses, it's a string, above 50, comma, and then 50 or below, also in parentheses, and then, So also in quotation marks, and then we put that in parentheses. So now all of this, again, could be written on one line, but for me, just so for readability, I put it all on different lines just because it's easier to read. Okay, so if we run that, then we'll see our additional columns that have been added to our data set. And that will be the last two columns. So it's going to automatically add at the end. Okay, so what it's done is taken every row, which represents a patient, and said, ask the question, are they above age 50 or are they below age 50? So this person is 50 or below, this person is 50 and above, and et cetera, okay? All right, so that's called data transformation. All right, so now we're gonna do a little bit more into the data exploration or exploratory data analysis. I already showed you the string or the structure function. Now I'm going to show you a little bit more with that. So we'll start again. We'll look again at what we did with string or with structure. I keep saying string because when I see str, I'm thinking string. And then we're going to look at head. I think we actually already did that, but I'll just put it on here again. I think I did those two already. I'll put it here. Okay, so this is our exploratory data analysis. We actually already did those two, so I'm going to skip over in the interest of time. And now we're going to get to the fun part. So we've done a little bit of cleaning, and now we're going to do some graphing in R. Okay. So before we do that, though, we want to do some basic data analysis, and we're going to start with descriptive statistics. So this is kind of a first start, no matter what you're doing with coding. If you're going to do any analysis, just do basic descriptive statistics, just so you know what you're dealing with. So that's mean, mode, quartiles, things like that. So for this session, I'm going to actually look at total cholesterol. I don't know why my mouse is just acting crazy today. Okay. So the code for that is summary. And then again, we're looking at our CVD data, and we're looking at the total cholesterol column only. And we could look at everything, but then it would take up a lot of space. But for visualization purposes, we're just going to look at total cholesterol. And why is it giving me this instead of everything? All right, let me do a correction here. And this is what I hate about coding, live coding. I did this thing 3 times and it worked, and now it's not. Okay, so what I've done here is I've used the summary function to look at all the different columns in the data set, not just total cholesterol. And this takes up a lot of space. But if we look at total cholesterol, okay, so it gives me character. Okay, so that means that the data in that column, there's probably there's either a character that's entered in that column or one of the rows that shouldn't be there. There's either an NA. I'm not sure what's going on there. I'd have to take a deeper dive. So again, this is where a lot of what you do with data and analysis is going to be back and forth, right? So I'm looking at total cholesterol. If I really wanted to look at it, I would have to go dig in and figure out why I'm getting this error. Now, I'm pretty sure the reason I'm getting this error is because there's a character in the numeric column that shouldn't be there. Now, for purposes of moving on with the session, though, I'm going to look at another column just so I can get you the information. But you can actually see it all here, right? A big clue, and this is just something that you'll learn just from coding in general. If something doesn't, when you get an error that looks like this, like say, for example, total cholesterol should be numeric. So why are we seeing character? That's because there's a character that's in there that shouldn't be in there. And so remember when I went back earlier in the coding, I only corrected the age and the BMI column when I could have corrected everything. So a lot of, again, what you'll do with coding is it'll be a lot of back and forth until you finally get to what you need, but we're going to keep it moving here. Let's look at, let's see, I said BMI should be in good shape. So let's change this to BMI. So we're going to look at we're going to get summary statistics for the BMI column. So again, that'll be minimum, maximum, median, and the quartile information. Okay, so this is what should have come out for cholesterol, and it did when I did it earlier today, but apparently the data set I had has some characters in the numeric column that shouldn't be there. Anyway, we're gonna move on. So with BMI, we have our minimum, we have our first quartile, median, mean, third quarter, max. Now, normally when you want to look at this information, it's okay to have the numeric information, but normally when I'm looking at quartiles, I'm gonna look at box plots, and so we're gonna do that later on. All right, so now we are finally ready to do some visualizations. Oh, stop right here. Any questions? Okay, and I'm going to read some comments. Hasna Adams says that CVD for younger than 50 tends to skew based on genetics, place of birth, occupation. There's probably a lot of different reasons. I study social determinants of health, and so what I know is that, excuse me, for people who end up being disadvantaged when it comes to social determinants of health, we often see CVD that looks like people over 50. Okay, CVD issues like BMI and glucose levels and things like that. So I think you're absolutely right. It's a great point. And again, this is where that expertise kind of comes in. You're able to help the stakeholder kind of know why the data reads the way it does because of your background and expertise. All right, so let's move on. Let's do some fun stuff now with the graphs, and my mouse is just acting crazy. Okay, so here we're going to do a simple visualization. We're going to do a histogram. And we're going to look at age, see how our age breaks down. Now, this is probably an important thing to do because it'll give you some clues about some additional analysis you might want or need to do. For example, if I saw that I had a lot of people that were older in my data set, I know that if I wanted to do some machine learning, if I'm looking for the relationship, say, between age and cholesterol level, if I know that my data set contains older people, then I'm kind of biasing my results in the direction of people having higher cholesterol levels because that kind of goes with age. So again, your expertise, your thought process, you got to always be kind of thinking, why am I doing this analysis? Why does it make sense? What do the results mean? And that's where being an expert kind of comes in play. Okay, so here we're going to do a simple histogram. This is the hist function. Again, we're looking at the age column. And here I'm telling our col equals blue. I'm saying I want to have my results be blue, or my histogram be blue. So we're going to run that. And so what you're going to see is the output is going to end up here in this files, plots, and health area of the RStudio. And you can see it gives you your counts on the y-axis, gives you your CVD, your age column, and it gives you the histogram, which breaks down, the number of people that fall under each area. Now you can set the number of bins. There's a default number of bins that I don't remember what it is off the top of my head, but you can actually change your bins. So if you wanted bins to be, looks like the bins are preset to be 10 years, you can preset them to be 5 because it just depends on your age group. Like say, for example, if you're looking at a group of people that are from age 0 to 5, you probably don't want to break it down into 10s, right? So you want to change how you break it down. So all of this is all customizable in R. Again, this is just a brief introduction. The book that I gave you will give you a lot of insight into things you can do to manipulate this data set. There's a lot that can be done with this data set. And I encourage you that once we put it in our GitHub site, to download it, play with it. That's how you learn and become an expert with the programming language. Okay, so that's our histogram. Now we're going to do a box plot. Now, again, anytime I'm looking at quartiles, the numbers are great, but until I see it as a box plot, I don't really, it actually helps your stakeholders kind of understand more about what you're doing in terms of the analysis. But the other thing is that box plots are really great for pointing out outliers. And so if I have a data set and I'm being told to analyze it, I'm going to always on my own do a box plot because I want to know what that spread looks like. That's going to tell me a whole lot about the type of analysis I should do and why. And maybe I should include some data, maybe I should exclude some data. So again, that's where these basic analysis will help you with that. So here we use the box plot function. Again, we're looking at the BMI column. We are going to give it the title box plot of BMI. On our y-axis, we'll have our value, which will be our counts. And so when we run that again, we're going to see that come out in this plots pane. And here we have our box plot. And it looks like the BMI is about, I'd say, eyeballing at about 27. But here you have an outlier way, way out there. This is a real tight box plot. You can stretch it out a little bit more, but you can see a lot of the values fell above 30. Wow. Okay, above that first quartile or that 75 percentile. That's a lot. Okay. And then finally, we're going to do let's see how much time we got. Ooh, 54. Okay. I may have to stop with the scatter plot because we're running out of time. Okay. I'll go through the scatter plot. The first thing you want to do before you do a scatter plot, though, is you want to check your length for both of your columns. And the reason is because in order to do a scatter plot in R, the length of both of the things, your variables you're looking at have to be the same size. So I did that by first doing length. Again, a function in R. I looked at the column that has age. I want to see the age versus total cholesterol. Again, I already know kind of going in, it's going to probably skew as you get older, it gets higher. But we're going to plot it out to see if that's correct. So we check the length to make sure that the lengths are the same, and they are. And this is your output here in your console. Then we're going to run that code, and what we end up with is a scatter plot. So actually, this doesn't look as, I mean, you would think that just based on what you know about aging and all those things, that we should see more skewed toward the older ages, but this is spread out pretty well, which says a lot about, and we know this to be true just from a public health perspective, that cardiovascular disease, we're starting to see it in younger and younger ages. And dare I say it, now that COVID is on the scene, this is going to change a lot for people under 50. COVID being a disease that, infectious disease that affects the cardiovascular system, these numbers are going to change. And that's really unfortunate. So my advice, I wear my mask all the time. I'm just saying, y'all do what you got to do. I know the last thing I want to be dealing with over age 50 is COVID. So take that as you will. All right, so the last thing I want to introduce is ggplot. And like I said, I will have to rush through this one. So there are a lot of different packages in R. ggplot is a very, very useful one. Also, dplyr is a really cool function in R, which allows you to manipulate data. And I'll just demonstrate that really quickly. But before we can do anything, we have to import our packages, which is maybe a little different from Python. I don't know that I do that a lot in Python. I guess it depends. At any rate, so we're going to import, sorry about that. We're going to import the dplyr and the ggplot. So dplyr is just a manipulation function in R, and ggplot is a data visualization tool. We are going to import both those libraries, and it should be really quickly and go really quickly, and it did. And now I'm just going to share some data. Here we're just going to do some data manipulation. dplyr is very great for data manipulation using something called a pipe. Let's see, I'll point that here. And again, I'll have more detailed information available to everyone. You know, I'll have comments in the code, so you explaining everything that I'm doing here, because I realize I'm rushing through. Okay. So here what we did was, again, we just use this pipe operator. We wanted to filter our data by age greater than 18. We put the pipe operator again, and then we want to arrange it by descending total cholesterol. So that means from the highest amount to the lowest amount. So when we look at our data, that's what we should see. We should see no one under age 18, and we should see our cholesterol column in descending order. So let's just take a look at that real quick. Let's see. Okay, so here's our ages. So I'm just, doing a cursory look. Nobody over 18 in that set. And what was the other thing we asked for? We wanted the data to be in order of descending cholesterol level. So let's look at cholesterol, total cholesterol. And there's NA in that column. Why is there NA? Okay, the NA I think was because there was a, oh, maybe it didn't have, where did that happen there? Let me just check something real quick. Wasn't expecting to see. Now you'll notice when you type in the first couple of letters in R, it'll give you whatever column that refers to. But let me just check out this total cholesterol column, because I wasn't expecting to see all NAs. Okay, so it looks like, all right, so maybe there's some, okay, there it is. All right. So again, when you get something that looks weird, just take a look. So I saw this looked really weird. These first couple of values had NAs for cholesterol, and I thought, okay, so what that means is that the data was missing. You'll have to use your own best judgment. Should you impute the mean? Should you use the mode, like the most common one, and put that in, fill it in for the missing values? You really have to give a lot of thought, especially with healthcare data, when you're filling in missing and NA values. Here, I just wanted to check to see what was going on in this column. I was like, it can't be all of them are NAs, and they're not. Here are the values here. And this is how I was able to do that. I just CVD data, $, the column I'm interested in looking at, and then I got the output, which is all of the data in that column. So that's what's really cool about R. Okay, so I think that just about wraps up this session in R. Let me just ask if there are any questions at this time. Like I said, I'm going to include all of the code. The code will have explanations. So for example, where I kind of brushed over that we were using pipes and looking, filtering and all that, the data manipulation, I'm going to actually have code comments in the code that are going to explain each of the steps, so that if you have any questions about it, you'll be able to look right there and say, that's why I did what I did. But for now, are there any other questions or comments? Thank you, Shalel, I pronounce your name. No question, although it was late, it was a nice refresher and able to follow. You are so welcome. Yes, this was the first time I ever taught R. So I was very nervous. I practiced as much as I could. And I actually did all of my dissertation research in R, but that was like, I don't know, 3 years ago or something like that. It was a long time ago. At any rate, it was great for me to be able to have this refresher to share with you guys, because one of the members of my committee has added another city they want me to analyze data for. So guess what? Now I'm back to doing R. So this was a great refresher for me. And thank you guys for coming. Again, I will try to have this put on our GitHub site by the end of the night. I also want to share that we are having a, BlackTIDES is having a event on next Thursday. See, is it Thursday or Wednesday? At any rate, we're having another event. It's tips and tricks for job hunting, I think, Sia. I think I got it right. At any rate, if you are interested in attending, we're all sold out, but if you're interested in attending, if you send an email, please be legit, not a bot, to contact@blacktidesdata.com. We will be happy to have you join us for that session. I also lead the coffee and code sessions. I did it again because out of my own personal need, I kind of had a selfish motivation for it, but it's great to have company with people who are working on personal projects. The coffee and codes are typically held on Saturday mornings from 10:30 to 12:30. And the last one for the year is going to be December 2nd, I think. And then we're going to start them back up in the new year. We're also going to be starting up our recruitment for people that want to participate in Black and Data Week, which is going to be during Black History Month. I'm going to share that. And I think I covered everything. See that? Oh, and one last thing. We're going to do test your Python. I don't know how many of you code in Python, but we're having a Kahoot game. I don't know if you're familiar with Kahoot, but it's like a online game where we're going to be testing your Python knowledge, and you're going to win prizes. The first prize is going to be the book by Dr. Joy Buolamwini, who wrote, she was the young lady who was at MIT. She was doing an AI project. She put a white mask on. The AI was able to see her face. She took the mask off. It wasn't. So she leads the Algorithmic Justice Institute or something like that. So that's going to be our first prize, is that book. And our second prize is going to be a $15 gift card to Starbucks. And I realized that with inflation, $15 will probably get you a lollipop from Starbucks. But anyway, so those are going to be our prizes for playing with Kahoot. So if you follow us on either Twitter or LinkedIn, you'll see the link to those events coming up soon. Again, if they're sold out, reach out to us at contact@blacktidesdata.com. and we will get you an invite. Last thing, please fill out the survey. We appreciate the feedback, good, bad, or indifferent. And again, all of the information, I'll try to post it tonight to GitHub before the end of the night, but please give me till tomorrow, because I'm gonna have a little bit more of those ribs and macaroni and cheese from Thanksgiving. Thank you very much. So I'm probably gonna be tired. At any rate, I'll have it certainly by the end of the weekend, that information, the slides, the code, and I think that's it. The slides and the code, again, with detailed comments explaining all the code for your use. And I think I covered everything. Anything else I'm missing? Sia. Sia's our operations lead. She's kind of the everything person at BlackTIDES. So thank you, Sia, for your support. I think that's it, Sia, unless you have anything else.
No, you got all of it. I hope you all have a nice evening and weekend, and thank you for coming.
Yes, thank you everybody for coming, and we will see you at our next event. Be safe, everybody. We'd like to thank everyone for attending today, and we invite you to visit us on our socials. We are on LinkedIn, GitHub, YouTube, and Twitter. You can also email us at contact@blacktidesdata.com. Once again, we thank you for your support. Yours in data, BlackTIDES.